Hi, thank you. Yeah, so as Matt said, I'm basically going to show off a proof of concept I've been working on and off with for about 4 years, mostly off, so it's not 5 years mature, but I'm going to show you what I have today. So as Matt said, this actually came from me. I was actually just at NAB about almost, it'll be 5 years next NAB. And I was just walking around the floor, and I noticed in the Adobe booth, they had some JavaScript up on a giant monitor. And normally I don't see code at NAB, so I stopped to check it out. And what they were doing was doing graphical overlays in JavaScript in After Effects with the new tool, I think it was new at the time, called Expression Editor. But it kind of blew my mind because like in editing, maybe that's normal, but like where I work in the transcoder and everything level, like programmatically modifying video is very complicated. Here they were just writing some JavaScript on the fly. So this is a video from that year. This isn't the demo I saw, but I think it's similar. So this was just kind of shocking to me, and I really wanted this power in our transcoder. So as Matt said, I sat down in the Cosmopolitan waiting for my flight and hacked something together, and this is sort of the result of this. But stepping back a little bit, obviously, you can kind of already do this in FFmpeg, so it doesn't really seem breakthrough at first. This is just the normal filter system. This is just a basic filter I wrote that sends the video, just samples it down to 1 FPS, rescales it. The chart at the top, the graph at the top is actually something FFmpeg can generate. It comes with a tool called graph to dot, and you can actually just put in the filter line, and it'll auto-generate this graph. So this is literally just taking the encoder, passing it to the FPS filter, passing it to the scaler, passing it to, it says null sync here. But the null source is really the decoder, and the null sync is really the encoder in the real world. A little more complex example. Oh, that did not format well on this screen. Here is a more complex one where we're using the overlay filter, and it's taking 2 inputs. We have our main input and our overlay input, and then 1 output. To get the animation, we're actually setting the X and Y values to an expression, and FFmpeg has this expression evaluator built in. So every frame, it's recalculating the X and Y position and generating this animation effect. So like I said, there's already a lot you can do with FFmpeg. The expression evaluation has this is the list of functions as I copied off the website. It's fairly robust. There's a lot in there. We have basic flow control like while and if and a lot of math. So you can do quite a bit. And then, of course, there's a ton of filters you can use. This is only the video filters, not even the accelerated one. These are just the basic video filters. So it's like 240. So combining the expressions and the filters, you can do a lot. But I still think there's quite a few limitations. One is the size. There's the argmax. You have to pass this in on the command line. So I think Linux is like 2 megabytes for the arguments. I think Mac might be 1. I'm not positive. Variables, you have to load and store. You don't really have name variables. They're really kind of irritating to work with. Poor code reusability. If I wrote a snippet and gave it to someone else, them integrating it into their code might be really difficult. Very low expressiveness. Very difficult to read the expressions after you write them. You can't really tell what they do just by looking at the code. And if you want to add a function or a filter, you have to recompile all of FFmpeg. And then at that point, you're basically running a custom fork. So anyway, I took a copy of Google's V8, which is their JavaScript and WASM engine that they use in Chrome. And I basically embedded that into an FFmpeg filter. I named the filter MIPP. So as I said, this has been going on very slowly over a number of years. It's probably only a couple dozen hours in reality. But I named the directory 4 years ago, and I can't remember why I named it that. I'm pretty sure the last P is pipeline, but I don't know what it stands for, but that's the name. So look, you're going to go through the code a little bit here. And I know this might be a little boring, but there's some really cool stuff in here I wanted to show off. So the MIPP class itself, this is all code I wrote. It's very straightforward. It's very simple. It basically just takes a script file, a path to a script file in this case. We could also pass in the raw JavaScript, but I'm just passing in a script here, or a path here. And then it has a receive video frame callback. So when we want to send a frame out of JavaScript into FFmpeg, this callback will be called. And then we have a send video frame, and that lets us get a frame into the JavaScript. Now, of course, V8 is in C++ and JavaScript is in C, so we have to have a C shim so that we can link the two, so I can compile and link. And the bottom is just the C shim. It's the same interface as C++, just a wrapper in order to get the linker to work. So diving into the code a little bit, this is the constructor of the MIPP class. So this is run at the filter initialization time. So this is actually done before we know anything about the video, before we know the resolution or anything. It's just when we're setting up the pipeline. This is all, it's C++ code, but it's the V8 interface. So what we do here is we set up a function template. A function template is kind of the body of the function, but it's not a function until we assign it to a variable, so you can call it. So this function takes 3 arguments, a width, a height, and a PTS, and then generates a frame inside of the JavaScript memory space. We do that by it accepts the function callback info. Again, that's part of the V8 library. And then we read the arguments out. Since we want to make this function a constructor, we take those 3 values we passed in and then set them to this value. I do want to point out that the actual code has a lot of extra checks and JavaScript-y things that I've eliminated for the purpose of the slide. But once we set all the values, we then create an array buffer of the width times height times 4 pixels to put the actual pixel data in. Right now, everything is just RGBA. It's not, we have to do the conversion, but FFmpeg does it for us, so that's pretty nice. And finally, we take that array buffer, set it to the data field, and then return the this argument. So this will give us a video frame in JavaScript. Next, very similar, we're creating a second function called receive video frame. And the naming gets a little confusing because like send calls receive and receive calls send, how pipelines work. So this is the function that will actually end up calling the callback. So this is the same thing. It's in JavaScript, but instead of taking width height, it's going to take a frame object and then read the width height PTS, and in this case, the data pointer actually back out, and then use that to call the receive video frame callback to get the frame back into the FFmpeg filter. Finally, we're going to finish our JavaScript initialization. We're going to take that video frame template, actually give it a function, video frame, so that'll be our constructor. And then our send video frame will call receive video frame. Finally, we set up our context, and the context basically creates our JavaScript environment. So at this point, we're ready to run code. But before we do that, or after we do that, we actually go in and grab a handle to the video frame function we just created. And what this allows us to do is now we can call new video frame from within JavaScript, but using this handle, we can also call new video frame within C++. So now we can create a frame at either layer. We load the script, we compile the script, and we run the script. Again, we're still in the initialization phase of the FFmpeg filter, so we get all that done and out of the way early. Then at that point, we say, hey, that script we just ran, does it have a function called receive video frame? If it does, remember that handle. And then finally, we have to have the function to send the video frame in to the JavaScript, which is the send video frame function. This time, it takes, this is called from C, so it calls the width, height, stride, creates a frame using that constructor we just created, actually copies the pixel data into the memory that it was allocated, and then calls the receive video frame that the user created. So this is the basic flow of that, the block diagram. So the code is a little complicated. Hopefully this is what makes it a little clearer, where we basically just send a frame into the user script and then back out, where the video frame is a little sidecar object that can be called from either place. So before I showed you the DVD bouncing logo, that's up on the screen on the upper left, and then now we have the replacement using MIPP, where we just pass in the script or the dvd.js file there. And then the dvd.js file is written on the right. I'm not a JavaScript programmer, ironically, so it's not the greatest JavaScript in the world. But just stepping through that code is very simple. If the pad is 1, means this is our overlay frame, so just remember a copy of it. If it's anything else, calculate our X and Y position. And then we call draw image, where we draw the overlay on top of the frame and send the frame back to FFmpeg. And then the end result is just what we expect, basically the exact same thing before, except this time written in JavaScript. One thing to note, though, when you include V8 is this is just the JavaScript language. This isn't a browser. There's no DOM. There's no CSS. It's just V8. So battery's not included. We have to bring everything in ourselves. One thing I glossed over in that previous slide was the draw image function. The draw image function, I didn't show you. It wasn't defined yet. And so where did that come from? What I did for that is I included the Graphics library. So Graphics is an accelerated 2D graphic library. Behind the scenes is very similar to HTML Canvas. I don't know this for sure, but I suspect it's what's used in Chrome to actually make HTML Canvas. And the API is nearly identical to Canvas. So by using Cairo, I can actually make an interface that's very familiar and kind of already exists. This is the interface, or all the functions that are part of the Cairo Graphics API. And of course, exposing all of these into JavaScript, we can write the bindings, which, as you saw from the JavaScript code, would be quite irritating to write all that code. Maybe some automated conversion tools. What I did I thought was pretty interesting and novel. Using template metaprogramming, I actually have the compiler generate the bindings for us on the fly. So here you can see this is a function, or a templated function called new object method, and on line 3, the part in orange. So that's taking a member of a class that is typed T that returns type R and accepts 0 or more argument args in the variadic there. So from here, I'm going to skip over the blue part and just go into the pink part on line 14. Just like before, we create a new function template, except this one's a little bit different. We actually take this func value and we read it from the args data, and we're going to set that in a second. And we read this value from the args internal field. So we're reading this function value and this value, and then we're calling it by calling func with the this and the args. The last line, 18, is where we actually set the func, which is the CB value, which is short for callback. And then back up on 4 is where we create our callback value. Here it's a C++ function where it's capturing the function we pass in, accepting our this argument, which is still templated, and then it takes our args. The reason why I'm spending so much time on this is I think it's really cool. So on line 5, we have this indexer up to, and this actually iterates over the argument list of the C++ function and looking for a function named toType, and will automatically find and use the correct function to convert from this JavaScript type to the type that the C++ class or the method is looking for. So this automatically creates all of our bindings for us. The next lines 6 through 10 are just there to handle void functions. Since you can't assign a void to a variable in C, we have to have a separate version, whether the function's void or not. So going back to our video frame constructor, we basically are adding a few lines here at the bottom where after we created the frame, I'm extracting a data buffer to it. I'm passing that to my canvas class, which is just a pointer. It's not copying the memory. And then I'm setting the internal field to this new canvas object I just created, which then becomes this in the previous slide. So now I can create bindings to the Cairo Graphics library just by specifying the name and the function. So I can basically add all those functions with just one line each, and it makes it super easy to bring new libraries into JavaScript. So updating our block diagram is this. It's basically the same as before, except we have the libcairo now. That's part of the video frame API. This is an example of that. So the clock is just literally code I copy and pasted off Mozilla's website as a Canvas example. This was web code. They're like, this is how you draw a clock. And all I did was replace the time.now with the frame.pts, and the clock automatically works. The text rendering is also done by Cairo, just literally line draw text, and also the overlay. So this, again, using web-like technologies makes it very easy to write and manipulate the pixels on the fly. So I'm actually a little ahead of schedule here, but so that's basically it. And I think there's a lot of interesting potential here. I think JavaScript is an interesting choice here because, like, if you're running your FFmpeg in the cloud, you could allow your users to write scripts and upload them, and then they'd be isolated and sandboxed. Obviously, we could make libraries of large code snippets and grow this over time. It would be, enable many, many new filters and many new options inside of FFmpeg without having to download and maintain your own forks all the time. And that's basically it for me.